Okay, simple events. Now, just so you guys know, again, this is page 5, starting our notes. I usually like to go ahead and put a date on them as well, so that way you guys are aware that if you are absent, you know to either go to the video, which we are currently recording, or you can go and look at notes from a friend or at my own notebook. You are going to need to make sure that you get colors out. Yes. Whether it's your highlighters or your color pencils, it doesn't make any difference to me. Just get them out.
Where's that green highlight? It's like my favorite one. Oh, here it is.
Okay, while you guys are getting your stuff out, I'm going to go ahead and get started. We have a few basic vocabulary terms that we need to make sure that you have an understanding of. If I'm talking about an experiment, this is different than when you're looking in science. This is a mathematical experiment, and it's basically an activity that's involving chance, like what we did with our want to make a bet activity. We did several different things, like tossing a coin, rolling the die, spinning a spinner, pulling, animals out of a bag. So these are all different types of experiments that each have different outcomes and probability or chances of things happening, specific outcomes happening. Then you've got what we have is called a trial. Now with a trial, that is, when I flip the coin, that's one trial. If I were to continuously flip the coin over and over and over again, those would be multiple trials. Okay, so that's kind of like a repetition or observation. I flip the coin, I landed on heads, I flip the coin, I land on heads again, flip the coin, land on tails, flip the coin, land on heads again, and it just keeps going and going and going for however many trials I want to perform it. So it's the repetition of the experiment or observations that are occurring with the experiment. The outcome. So whenever you hear me talking about an outcome, that is the result of the experiment. So when we flipped the coin, the result was we landed on heads. Wasn't what I wanted, but the outcome that it actually landed on was the result of the experiment. Okay, then you have event. And that's the set of one or more outcomes. So that's basically what you're looking for. So when I said, hey, I want to flip the coin and I want it to land on tails, that's the event. That's what I was looking for. Wasn't necessarily the outcome that happened, but it's the event that I set, the precedent that I set. So set of one or more outcomes. Okay, now we have our basic number line for probability. And probability is simple, guys. It has a very, very simple range of values. The lowest that a probability could be is what? Anybody? Zero. That's the smallest chance that could ever happen, is it not happening at all. The largest point for probability is what? 100 what? Percent. Not just 100, it has to be 100%. Probability, its most common form, is not actually in percent, it's actually in fraction. So if it's a fraction, what's the largest number in fraction form that it could be?
5/5.
1. 1 whole. 1 over 1. That's the largest it can go up to. Okay? So let's go ahead and get that number line written down. Okay, so again, you have a starting and a stopping point here at the value of 0 or 0 over some number, any number, as long as 0 is your numerator, or 0%. When you're in a situation like this, these values right here are called impossible. When it happens directly at 0, 0%, 0 over a number, that's an impossible event. Halfway in the middle, that's 0.5, or 1/2, or 50%. That's the coin, right? 50% tails, 50% heads. This situation is what we call equally likely, or as likely as not to happen. Equally likely. Then at the far end of the spectrum, we have 1 whole, or 1 over 1, or 100%. At this end, we call that event certain. It is certain to happen. Now obviously there are things that happen in between, like when we were rolling the die and we want it to land on a 5 or a 6. That was a 1/3 chance. 1/3 is not impossible, it's not equally likely, it's not certain, but it happens in between that impossible and equally likely situation. So anything that occurs between 0 and 50%, or 0 and 1/2, or 0 and 0.5, anything in between there, we call this unlikely. So if it's greater than 0 but less than 1/2, it's an unlikely situation. Greater than 0 but less than 1/2. Greater than 0 but less than 1/2. That's an unlikely situation. Then you've got anything that's greater than 1/2 but less than 100%, less than 1 whole. That's called likely. So it's greater than 1/2 but less than 1 whole. That's your probability line. And again, there's no such thing as probability being greater than 1. So you got to keep that in mind. There's no such thing as a negative probability either. All right. Probability itself. A lot of times the way that you're going to see it written is P and then parentheses and then whatever your specific event is. we indicate that that's probability of. And that's always going to be equal to your event, how often your event is going to occur, out of the total. So like how many, numbers happen to be a factor of 4 over the total number of numbers on that spinner. So this specific event over the total. So I want the probability that I'm going to pick a month with 28 days. I want the probability I'm going to pick a month with 28 days in it. Is that impossible, unlikely, equally likely, likely, or certain?
Certain. Oh, yes. Every 4 years it's 0. What? What?
That's a little off there. Somebody said unlikely. Why did you say unlikely?
Well, I said unlikely at first because it was February, which had 28 days, but then I remembered that each month has at least 28 days.
Very good. Okay, so starting off saying unlikely because most people think, oh, it's just February. February is 28 days, right? However, there is a January 28th. There is a March 28th. There is a December 28th. Every single month has 28 days in it. Just some have more, than others. So you have to make sure that you're being aware of anything that might be trying to trip you up. So picking a month with 28 days, that's every single month, right? So when we're talking about the specific event, 28 days, that's all the months. Which is how many months? 12. And again, that's out of all the months, which is 12. So if we've got 12 out of 12, what does that equal? 1 whole, right? Which is certain. So that probability is certain. It's 1 whole, or 100%. What about the probability that you're going to roll a number that is greater than or equal to 3? Probability that you're going to roll a number on a standard die that is greater than or equal to 3. Who can raise their hand and tell me what numbers satisfy this event? Vincent? 3, 4, 5, and 6, right? So that's the numbers 3, 4, 5, and 6. How many numbers is that? 4 numbers, right? We have 4 numbers. How many total numbers are on the die, guys? 6. There are 6 total numbers on the die. So we have 4 out of 6. Can I simplify that? What does 4, 6 simplify to? 2/3. And that would be what probability? Likely. Okay? So this is a likely probability. You could say 66.6 repeated percent or 67%. I'll leave it up for about 10 more seconds and I'm going to flip. Okay. Again, the notes are always available, that if you didn't get a chance to finish copying down like one part of a question, you are always welcome to come up after we're done with the notes. You can look at the notebook, you can look at a Friends, you can go online to eClass, you can look at the video, you can scan through the video real quickly to wherever it would have been left off at, okay? There's lots of options for you to make sure that you're able to keep up with the notes. All right. And if you like writing on the back of your paper, by all means, do so. Me, I don't like writing on the back of mine, so I always write on just the fronts. But if you want to flip it over and you want to write on the back, then do that. But see, you can already tell it bleeds through for me. So this is page 6. All right, talking about a complement. Complement when we talk about probability. So you're going to hear the word complement often in math. We've got complements for geometry, we've got complements for probability. The complement for probability is the set of all outcomes that will not occur. And that's real key. The set of all outcomes that will not occur. So when we are playing the activity, I'm gonna use you, Jane, as an example. The second activity that we had completed, the rolling of the die, Jane made a bet based off of it not happening. When I told you guys, hey, all of us are making these bets based off of the fact that the event is going to happen. How much would you be willing to bet? Well, Jane unknowingly did a complement. She placed a bet based off of it not happening instead. Okay, that's called the complement to a probability. So whenever you see something like, oh, the chance of rain is 70%, well, its complement is going to be what? 30%, because that would be the chance that it's not going to rain. Okay, so our complements are our not probabilities. So I'll just do one quick example because I want you to be able to have plenty of time to work on your assignment. So if I know that the probability of red occurring is 3/8, I want to know what is the complement. So probability that red is going to occur is going to be 3/8. What's the complement? Anybody? Brent?
5/8.
How did you figure that out?
Because 5/8 plus 3 equals a whole.
Very good. So basically you're taking the probability that it's going to occur and you're subtracting it away from one whole, because probability is always based off of one whole. Okay? So the probability that it is not red, because remember complement is not, would be to take that one whole and subtract the probability that we actually have. So we're going to subtract 3/8 away from one whole, which would give us 5/8. Any questions? Okay, so your assignment tonight is going to be a simple events worksheet. It does have a front and back, but it's very, very quick.